Let's deduce the general formula for a geometric sequence. We'll start by looking at one with numbers. So the first term is 3 and the common ratio is 2. So the second term is 3 multiplied by 2, which is equal to 6. The third term is equal to 6 multiplied by 2, or 12. The next term, the fourth term, is 12 multiplied by 2, 24. The fifth term is 24 multiplied by 2, which is 48. But what's the nth term of this sequence? For arithmetic sequences, it was fairly clear, but it's not as obvious in this one. So let's have a look at the general case and see if we can deduce it from there. This time u1 is u1 and r is r. So u2 is u1 multiplied by r. u3 is u2 multiplied by r. But we're going to do a similar trick to what we did with the arithmetic sequences, which is we know that u2 is equal to u1 times r. So this is going to be u1 times r, and that is being multiplied by r. So we have u1r squared. u4 is equal to u3 times r. But again, we know that u3 is equal to u1 times r squared. So replacing that into the formula, we get u1 times r squared multiplied by r. That is u1 r cubed. u5 is u4 times by r. But we know that u4 is equal to u1 times r cubed. So u4 times by r becomes u1r cubed multiplied by r, which is u1r to the power of 4. And hopefully by this point you have spotted a pattern. un is equal to u1 times r, and the power of r is always 1 less than n, so n minus 1. That would suggest that for our sequence over here on the left, our nth term would be 3 multiplied by 2 to the n minus 1. If you substitute in n equals 1, 2, 3, 4 and 5 to that sequence, you will get these values. So in general, we have, for any geometric sequence, un is equal to u1 times r to the n minus 1. And you're given that result in the formula booklet, so you don't need to memorize it, but you do need to know how to use it, which we will see in the next few examples.